Good morning everyone. So here I am going to explain the basic concepts inside the inverting amplifier. So inverting amplifier, the name itself indicates whenever the output signal is 180 degrees phase difference, then we can call it as inverting amplifier. So this inverting concept is based upon the operational amplifier. So basically operational amplifier is configured into two types. One is open loop configuration and the one is closed loop configuration. Open loop configuration is nothing but absence of feedback resistor. If an op amp without feedback resistor, we can conclude that that is operated under open loop configuration. The application of this open loop configuration is voltage comparator. So by using of open loop configuration, we are going for compare the voltage levels by application of two input signals. But don't try to operate the op amp in large time for the voltage comparator because it is physically damaged. And then closed loop configuration. Closed loop configuration is a concept inside with the presence of feedback resistor. So this feedback resistor will introduce two types of feedbacks. One is negative feedback, another one is positive feedback. So as we know from the basics, negative feedback, it is a concept we will use in amplifiers. Positive feedback we will use in oscillators. So if an amplifier with possess the negative feedback, definitely op amp will operate in linear region of operation. If an op amp will possess with the positive feedback, definitely this operational amplifier will operate in saturation levels or in saturation region. And then we'll go for how the inverting amplifier will works. So this is a schematic of inverting amplifier. It contains non-inverting input and inverting input. So here I am physically connect the positive terminal to the ground. By connection of this positive terminal, the same potential will exist across the inverting terminal also. This concept will disclose the virtual ground concept. So I am not physically connect the negative terminal to the ground. I am connected physically negative terminal to the input signal. Even though this connection of the input signal, but across this node, the same potential exists with the 0 volts across the negative terminal also. By this is the way, this is the fashion we will conclude the virtual ground, because both are close friends. Why? Because by upon the connection of positive terminal to the ground, the same potential will exist across the negative terminal also. So if it is in a node contains 0 volts, obviously the current flowing through this terminal is also equals to 0. If it is current flowing, this terminal is equal to 0, it offers high resistance. So theoretically, we can conclude that op amp, the input impedance is infinity, whereas practical at around kilo ohms. Let us we will analyze this operational amplifier by the application of KCL across node E. So always current flows from V into this node and output to this node because of according to the Ohm's law. Electrons will flows from higher concentration to lower concentration because of it is a lower concentration because it have the potential as 0 volts. Hence the electrons will flow from higher concentration to lower concentration. Obviously we can say that it is a higher potential compared to this potential. So electrons will flows from this node to this node. So we will implement this concept inside the KCL. So this is the fashion where I1 equals to V in minus 0 over R in plus V0 minus 0 over RF. We will equate the both the currents because I1 equals I2. So how much current will flows from here? The same current will flows across this I2 also. That's why we have right to make I1 equals to I2. So when I1 equals to I2, this is the fashion. So it is a I1 concept, it is I2 concept. So we are going to calculate the how much voltage across the output, that is V0, where V0 by Vn equals to gain. The how much gain is offered by this inverting amplifier. That is an ultimate aim of the this class. That is A equals to V0 by Vn equals to minus RF by Rin. Obviously this minus indicates the 180 degrees phase difference. By this ratio, I can conclude that the gain of this amplifier is purely basically depends upon the feedback resistor. If you want to increase the gain of the schematic, you need to be reliant on feedback resistor. If you are going to increase the feedback value, definitely you will get the higher gain. By this concept, I can conclude that op amp, it is a voltage control voltage source device. The output voltage is controlled by the input voltage. I can conclude that op amp is a voltage control voltage source. What about the primitive components, primitive active components like BGT and FET? I would like to show, so you will get some surface knowledge. So here, op amp, it is a voltage dependent voltage source or voltage controlled voltage source, whereas FET is voltage controlled current source, whereas BGT is a current controlled current source. Let us give surface knowledge regarding to how it is in a BJT is a current control device. So it is a common emitter configuration because emitter is common for both input and output. So it is in a base terminal, it is in a collector terminal, right? So the emitter is common for both input and output. We can conclude that it is a common emitter configuration. Configuration nothing but arranging, the way in which terminals are arranging. Whenever emitter is arranged as a common for both input and output, we can conclude that it is a common emitter configuration. Let us. So it is an output current, it is input current. We are applying the signal across the base. The output current is controlled by the input current. Then this fashion we can conclude that it is a current controlled current source. It is for common source configuration because it is a source, it is a drain, it is in a gate in FET configuration. It is valid for both FET and JFET also, right? So output current is controlled by the input voltage. So here, this is the fashion how the active elements will regard into the behavior of the voltage and current source. So op amp will possess voltage control voltage source. FET or JFET will offers the voltage control current source. BJT is a current control current source. It is this concept will 100% useful in public sector examinations or PSUs. Definitely you will get a one bit question. Let us, we'll go for back.